Okay, here comes our fourth one. For exam one. Here we go. Um, so we're talking M108, spring 21. Again, exam one review. We're talking D. Okay, now number 10, 10th problem. Here you've got a panel of 12 people. 12 people. I'm just going to call them 5X's. Let's say there would be parents, teachers, whatever it is, but I'm just going to call them very simple 5X's. You got 5X's. They belong to one. They're in the same category. You got one Y, only one in this category, and you've got 6Z's. Right, so they may make up some story, and the X's will be a certain type of person or thing. The Y will be a person or thing, and the Z's, but they'll all be in the same category. 5 of these, 1 of these, 6 of these. Okay, how many? As you can see, so there's 5 and 1 is 6, and 6 and 6 and 6 is 12. So it all works out to be 12 people. Fine. Here's the question: how many? And this we didn't see on our video, so I got to explain this well, but it's not too big of a deal. How many distinct the orders? Yeah, that's how they put it. How many distinct orders? And they're being a little bit fancy with their language of the question. Can they be seated? Now, seated, we're going to have to discuss that in a second. If two people of the same group, group, right? This is one group, X is one group, Y is another, Z is another, of the same group, right? Let's say, some sort of convention, and they're coming from different states, 5 from one state, 1 from another state, 6 from another state, of the same group, which would be, in my case, in the same state. Two people of the same group are considered identical. So if you put two people, let's say A from X and B from X, they're next to each other, or B and A is seated a different, or instead of there's 12 seats, right? So let's say seat number 6. If A from X is in that seat and B is in seat number 7, or vice versa, it would be the same thing. Same group are considered identical. Identical. That L in there is wrong. Identical. Okay, so now, what do you do in a case like this? Now, what's really going on over here? Just imagine there's 12 seats, right? You're going to put them in seats. 1, 2, 3, 4, 5, 6. Right. So someone from X is not identical as the someone from Y. So if an X person is here and then a Y person is there, or a Y person is here and an X person is there, that's considered two different things. So order is important to a certain extent, right? Except that if they're the same group, then they're identical. But besides that, order is important. So hold on, let me show you what to do in a case like this. Let me finish off my illustration. My lousy illustration doesn't really do much. It does a little. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 seats, and you're putting the different people in there. This is what you do in a case like this. Take all the people, put that in the numerator with a factorial. That's all the people. Then each of the groups with their own factorial in the denominator. 5 factorial, 1 factorial for the Y people, and for the Z people, 6 factorial. And then we work this out. So we talked about how to work out something like this. You go 12, take the top one with its biggest of the denominators. Go 12 minus 11. Don't even try to do this with a calculator yet. First, clean it up a little bit. Reduce it a little bit. 12 times 11 times 10 times 9 times 8 times 7. You reach 6. Stop. Okay, they're out of the picture now. These are gone. 1 factorial is the same as 1, so it doesn't do anything. So the only thing that I have to reckon with over here on the bottom is 5 times 4 times 3 times 2. I don't need the 1. Okay, let's cancel out what we can. 4 times 3, how much is that? 12, right? That takes out the 12. 5 times 2, how much is that? 10. That takes out the 10. What's left standing? Then you take out the calculator. You click on the calculator. You do 11 times 9 is 99. 8 times 7 is 56. 99 times 56 should be 5544 if I got that right. And that's it. The problem is finally over. That's what to do in a case like this. Here we go. That's problem number 10. Okay, problem number 11. We can put on the same page. It's very short for a change. We got a really short problem, and not a hard one. I think you'll agree with me. Problem number 11. All it's asking us to do is write the decimal 0.83 or 0.83. Either one is good. The same thing. 0.83 or 0.83. Write it as a percent. As a percent. Okay, that's what they want. Answer. Take the if you're going from decimal to percent, move the decimal place 2 places to the right. It becomes 83, and tack on a percent sign, 83%, and there is your final answer, 83%. Okay, now we need a total clean piece of paper. We need to go to 12. Total clean. For number 12, and hopefully we'll get 12 on there. Okay, here comes number 12. You've got another one of these spinners, and I might have to do part of it in the next video. I don't know if I'll have enough time to finish it all, but it's not a big deal. It's a lot of stuff I got to write, but it doesn't turn out to be a big deal problem. So on the spinner, you're going to spin it 1,000 times. Someone's going to spin it 1,000 times. Okay. Now, what does the spinner have? It's got colors on it. This is black. Again, it's 10 slices like a pizza. This is gray. This is gray. This is black. This, what is it? Oh, 1, 2, 3, 4, 5. This is white. This one is white. Another 5 on this side. This is gray. This is white. This is black. And this is white. Those are the colors on the spinner. Here's the table. Small little table, not a big deal. W, G, and B. White and gray and black. Spun 1,000 times. 393 were white, so landed on the white. 309 on the gray. 298 on the black. And if you total that up, it should be 1,000. Okay. The answers should be answers in decimal. Question A. What's the probability of G? All right, the probability of G is 309 over, how many times was it spun? 1,000, and you got 309 that are gray. 309 divided by 1,000 on your calculator. You don't really need a calculator. It's going to be 0.309. Problem over. That's the answer for A. B. What's the probability of? This is very important. The question is the experimental probability of G. The next question is the theoretical probability of G. They're trying to theoretical probability of G. That's a different answer. Let me show you exactly what I mean. The theoretical probability of G is really, how many G's are there? There's 3 of them out of 10. So that really should have been, three. Theoretically what should have happened is there's 3 chances out of 10, the probability of landing on gray. What's that translate into in decimal? 0.3. So the theoretical probability is not actually the same as the probability that actually happened. Okay, that was problem C. That was number 12C, 12B. I meant. Now we're up to C. Okay, pick the true statement, right? The true statement. You got to pick the true statement, and they'll give you something like the larger number of the larger number of the larger number of spins the greater the likelihood of the greater the likelihood, the experimental probability will be close to the will be close. The greater the likelihood, the experimental probability will be close to the theoretical. And you pick that is true. That's the true statement. The more you spin, the more likely you're going to get to 0.300 or 0.3. The more you spin, the greater amount that's the true statement. So there'll be a couple of bogus statements, and that's the true statement that you want to pick for C. Let's go to the other. Let me tell you what else they'll be there for you to possibly pick. For C, this is still C. We're still talking about problem C. Let me show you what the other choice is. That's the choice to pick. What will be the bogus statements that you'll see? That you don't pick that one. Pick this one right over here. Check on this one. But here's a bogus one for C. The experimental probability will never be close. That's not true. Will never be close to theoretical probability. You don't pick that. That's not true. And the other thing that's not true that you don't pick for C is the smaller, just the opposite of this, the smaller, I'm going to put the smaller number of spins, the greater the likelihood that the experimental probability, the less you do, the greater the experimental probability will be close to the theoretical. Will be close to the theoretical, and that's patently false.
Now you gotta get up.
So that's what you don't choose. The first statement is the one that you do choose. Okay, that problem is done. Fresh piece of paper. We may have some time to do one more on this video. Here we go. Problem number 13. Let's see what we can do. Yeah, it's a short problem. Problem number 13. Problem number 13. A ran, and as I just use the number, just the name of the person is A. A ran for president of a club or whatever it is, or of a class. I can get this on. There's 60 members in all. 60 members of the club in the club. 60 members in this club. Okay. A received, here's another piece of information, 60 members. A got 39 votes. Got 39 votes. Here's the question, that's all the information. What percent of members voted for A? Voted for A. There's the question. Here's the answer. It's pretty straightforward. 39 out of 60 voted for A. Divide 39 divided by 60, and then you'll get the fraction. You do that division with the calculator, you'll get the decimal. From the decimal, you can go easily to the percent. Move it over 2 places to the right, and tack on